Anyways, I think we can start now. It seems most of the people have set it up. The organization of this lecture workshop will be that first we will study a few simple examples, build up different things, and then you have, takes about 1 hour to study techniques and stuff you can do. And then there's 1 hour of chaos, everybody doing their own thing. Anyways, most of the things here are just JavaScript canvas and JavaScript. I have some tools here or useful scripts that makes our lives easier, but it's mostly very little stuff. So let's take a look at the first thing, is the setup. The program you started earlier allows you to do things such as when you save in the editor, it will automatically update the browser, so you don't have to manually refresh the page every time. So it helps with the workflow and helps you iterate faster. So in the beginning, we always do this setup thing where we say that, oh yeah, we want a place where we can draw and it's the exact size as the window. So this is just annoying setup that we need to do. And then we can use this context or the canvas or the thing where we can draw to execute different commands. So here it's fill rect. And so, no, I didn't want to press that. We can go on to the shapes thing. Shapes. And here we can see different things we can draw. So basic things like we can draw a rectangle, we can draw a square, and we can create the path. So we start from somewhere and then draw some lines, and then we ensure that we actually draw it on the screen, this stroke command. Because this part here actually doesn't draw it yet. So when I remove this part here, you can see this thing here disappeared because now it's not being drawn. So, and we can of course create the path. So path is this effectively a polygon that we can fill, and we can also draw arcs here, which is let's do 2.5 for example. So you can see the circle changing on the left. Then we can go on to actually changing the color. There are different ways how we can set the color. One is using the hex value RGB. This is the common way used in CSS. But probably more useful is setting with hue, saturation, and lightness, because we can more intuitively say that, oh yeah, I want this bright colors and this saturated. So it's helpful. And I also, so when we go to this stroke example, we see similar things. We can change the way the lines are drawn. So and finally, we can take something like from these basic elements, we can already draw some gradients. So here we just take coordinate x and fill a rectangle every 10 pixels. And here we use hue, which is the x coordinate times some value. Phi is this mathematical number that's quite useful here, but and we get this result here. We can also use it here in the as RGB, so we can modulate the R value, and we can also, like everywhere, we can just throw random functions together until the result looks nice. When you can, eventually you can start doing those function manipulations, how one result applies to another, so you can easily construct these color gradients and different things. And finally, we can draw text. And here again, we specify the color and whether we want to draw the outline or fill it. And there's this convenience logging thing that helps us log things here. Because the browser log can actually break quite easily if you try to log some million things in a single frame. So this helps prevent it somewhat. Anyways, any questions about this? Yes?
I don't see the log in internet page.
Use Chrome. This is the answer. If you are using Internet Explorer, that's the wrong thing.
The source of all problems.
Yes, I'm using a lot of newer JavaScript things here to make our lives easier. And I really don't care about Internet Explorer.
That's the default thing that opens.
Yeah, it opens your default browser. So, anyways, so we can go on to more fun things like time. Isn't it beautiful? So what we do here now is that instead of drawing the picture once, we are drawing it every 33 milliseconds here. So we clear the screen and then draws the text, which is the current date. Why it's this weird thing, it's just the way how you get the milliseconds in JavaScript, the current time. So, but currently this set interval thing isn't actually quite what we want, because this has timing issues and we want to actually draw every frame, and this timing isn't good enough. So we have to do this mess here, which is the time example. So, okay. Here we record, say that yes, we want to draw a frame in the browser, and then we want to also get the actual time, how much has elapsed before since the last frame. And I have this convenience function now here that gives you seconds since you started the code. So this is quite useful to do some visualizations based on that. So for example, I could use this, use a sinus here, No, I want it to be lower. So x coordinate, y coordinate. So we can see here this value is now moving up and down. So okay, now we can start moving on to the interesting, the actual interesting stuff. Is we can start drawing moving things. So here the principle is that we use this sinus function based on our current time to pick the x position on the screen, and then we use some other formula to pick the y position on the screen. Here, this rx and ry, and then this calculation ensures that we actually center it on the screen, and then we draw it, and we use this hue-based values to draw this dot on the screen. And one thing that we also did here is that we said that don't erase everything that we have, but use some alpha value here. So this thing here. So this is actually what we are drawing on the screen. But when we don't erase everything on every frame, we can make it look fancier. So, and here we just use some other rectangles to draw here and here. So, and when let's say we make those rectangles here larger, then we can do something like this, which is kind of targeting thing or whatever. So we are just drawing these rectangles exactly where the dot is here. So, any questions about this? Okay. Then we can move on to. We can actually animate shapes now as well. So here we use this to draw this arc based on time. What is the start angle and the target angle, I guess. And then we, based on that, fill things. But we can also draw these shapes using those move to and line to based on time and sinus functions, and to combine them. For example, here, this shape here uses sinus function for the upper part and sinus for the lower part, and then it combines. So here we take this circle. So when we take a circle, we can take this thing here. We know how to find points here using cosine and sine. So what we can do is we can start moving this radius. So making this radius based on the angle. So you can see this is the end result here. So when I take away this modulation on the radius, we get the circle, and then we can start layering different effects here. So I can add even more things based on time and combining different functions to get fancy shapes. These, of course, need some machinery to actually draw this line, but you will get this once you start playing it with start playing yourself. So we can take a look at, we can also animate things or paths themselves to get some naturalistic motion. For example, for each of these points, I use sinus to move it up and down, and I usually just start guessing that, oh yeah, I want something that is based on time. So I start playing with those numbers here until I can find that, oh no, that's not what I want. I want something like this. So, and of course, when we mirror it or do the same thing on the other side, we get a birthday thing, kind of. So, and one of those extra fancy tricks is that one thing is usually boring, so then make tons of those and make them with different speeds and different sizes, and you get neat effects already. So, any questions about getting your time, about time, or understanding this concept of so effectively we have time here, like time, and then we can take different functions and use this as our whatever size, rotation, position on the screen, and color to do different effects. And eventually, when you put those together, you can already animate these things. So now, when we have this animation, some sort of animations, it would be useful to draw it onto different locations. So now we can start moving our paper around. So, for example, here you can see this context translate. When we just draw it here to 0, 0, we get this. It's in the upper left corner. But to make it more comfortable, we can say that the 0, 0 position of our paper is the screen center. So we move it to the screen center, which is half of the screen width and half of the screen height. And then we can just draw it here in the center. And we can also rotate the screen. So when you look at the code here, you see that this drawing code here is pretty much the same thing, except now it rotates because we rotate the paper. And also, oh, this is important thing here, context save. Otherwise, it will start to move your things every frame, and it will just disappear somewhere. So it's useful to save and restore it as the need arises. Of course, we can also change the scale of things to get distortions different ways. And this is using this context scale function. And so the drawing code is pretty much the same here again. And now what we can do with it in practice is to start drawing the same thing multiple times. So here we say that, yes, we want to draw a tree. We have this function tree. And then we say that, oh, let's draw a tree branch here. So let's show. So one tree segment looks like this. So now we can do we can draw another tree branching out to here and here by just making two drawings of the same tree, but smaller and just rotated. And here we have this rotation and drawing the tree again recursively multiple times. So we can do this with this code. We have just drawn the same thing multiple times recursively.
Fractals.
Yes, fractals. And as usually, the fun thing now is to make it move, which looks like this. We could make it scale or kind of do different things, or we can add even some, let's add one level of the tree here to the center as well, so we can see kind of slowly doing stuff. So let's make it a happy tree in the wind. But we can also make it more fun, is to make it here, this mouse example. So we can capture the mouse position on the screen. Here we use translate into from the screen position to -1 to 1 scale. So we can use this to manipulate different things instead of using time, but we can also, of course, combine them and, in multiple ways. So we here, instead of rotating by some constant amount, we use the mouse X and Y position. And of course, now that we have this beautiful tree thingy, we can make it colored and make the colors move based on time and where they are drawn or something. So we keep on layering these different effects until we get these neat looking things, and quite fun to play with. So, any questions about transforming or the concept of transforming? Anybody really confused? No? Well, good. So, now that you already know everything about how to transform our paper, you can start learning how to smoothly move things. So we take this LERP example, which probably looks a bit more fun, or smarter at least. So what do we do here? First, let's take a look at the red dot moving from one point to another. So here we use this function called lerp, which is finds the position between 2 points based on some value from 0 to 1. So when we have this point here, and we want the point between here, let's say here, it's about quarter away there, so we can use this lerp function to find this position between those 2 points. So we can animate this dot moving from one place to another. And what we can do with this moving towards something is to make this tail here. So instead of these dots are always moving towards the next thing, kind of taking a small step towards it. So when you take here the followers, here we set up this tail thingy, and we say to each follower to move towards the place that it should be. So here is this lerp that we take the previous position, the target where we want to move, and then move this 1/10 of away towards that target. So this means that we get this tail here. And when we modify this number here, how fast it tries to move, we get this faster tail. We can. Did this part make sense? No questions? Okay. One of those things that you might think now that, oh, this linear motion looks really boring. I want to make it more interesting. So this is where easing functions come in. They help to make our animations more interesting or do more interesting stuff. So we have this function which takes in this time value, for example, so from 0 to 1, and then it translates into another value that you can use as where you want to linearly interpolate, or the lerp thingy. So we can, what this allows us to do is to get these different movement effects using different functions. So what it will look like is that we have this many of these functions. They all start at 0 and then at 1. So, and now when we use instead of this exact time value, we can use this modified time value that has a different path here, as we can see. So this is our function, and on the x-axis here is time. We can see how we, instead of using the time value, we can use directly some other value that's based on some function. And of course, we can throw together those functions ourselves however we want to get different behavior for rotation, movement, scale, so we can do different effects. So here's a simple example where you would use it. It's a drop down thingy. So we have this thing that drops from the top, and we use this ease in out quad to get our Y position there. This is to give it this weight in the movement. So, and we of course then rotate using some function and combine different functions to get scaling as well. And this gives us more interesting and kind of more natural looking animations. And one thing that we can additionally do to make animations more natural is to start putting some brain into them. So we have different states. For example, this dot first moves towards this dot here, and then pulses at that position for some amount of time, and then it moves to the next position. So we have this flob that moves from one position to another. So here we can see this brain, which is that it has this animation time. How long does it take to do this one current animation? and state that it's moving. And so when it's moving, it tries to, well, when it finishes moving from 0 to 1, then it starts the other activity here. And it toggles between those two activities. And we can figure out the position based on what we are doing and kind of and figuring things out. Of course, one thing isn't fun enough, so the usual solution is to do it multiple times. And we got ourselves a swarm of flops. So, anyways, now that we have mastered animating and making natural movements, we can make them interact somehow. So this means that we can, let's say that they are animated, and when they are near each other, let's draw a line between them. So this is the easiest interaction, that, yeah, let's draw some line between them, and it looks already a little bit cooler. And so what we can do, now that we have this animation thing, we can start playing with time. Instead of incrementing the time every frame for 16 milliseconds or 33 milliseconds, we can manipulate the time here based on some sinus function. So we can now see those all of those, the swarm starting to move slower and faster depending on some sinus function. Of course, we can make this function more complicated and more fancier. And of course, there are different ways we can make things interact. One is using physics. We use gravity here and speed and velocity. Or we can use attraction to each of those points, so to make them come together in a single point and interact with each other. Or we can make them collide. If you want, if you don't like circles, then you can also use these. And if you're emo, then this helps. Anyways, so there are different ways we can make things interact. And the final step is, or not the final step, and one additional approach is instead of using some things that are on the screen, we use greets to simulate some behavior. So here I just randomly turn on, turn off a greet light. And of course, one of those usual examples is the Conway's Game of Life simulation, which is based on like moving things, or each of those cells depends on everything else that surrounds it. And we get this interactive behavior. And of course, we can do some fluid simulations as well if we want. Here we just figure out the next cell based on the the cells below it. So these are the techniques that you can use, and here are few of those examples that were during the Ludum Dare competition as screensavers. So here you can see that we have these shapes based on circles and some random function that tells it how to move, and we can get these different behaviors. And then here we have just these letters LD36 defined as shapes, and we jitter all these corner points here, so we get this shaky effect, and we add some rectangles here to get those raster lines. Of course, we can do this trailing thing based on some other points as well, or we can use this connect near things that are near each other and make those forces interact and kind of move together and go apart. And we can also symmetrically draw things and based on states start moving them together and moving them apart, and so we get these cool effects. So now these are all the examples I have here. Here I have also different ways of how you can write them. There are many tools around there to help you with them. And there's this guy Keith Peterson who has pretty nice examples and tutorials how to write these things more in depth. And generally there's this called demo scene where you effectively code these visual things and make cool stuff looking visual. So here's one example, and when you have mastered all those things, you can start doing really cool stuff. This has actually audio as well, but oh well. So, anyways, now that you know all the techniques, you can start building your own thing. Pick whatever starting point feels comfortable to you. If it's drawing simple rectangle on the screen, that's fine. If it's you start to want to play with different things colliding, then that's fine as well. So, and I'll be moving around, and you can ask me things and how to get started on things. Anyways, so how to get started is you can make a new folder here. Let's say, I don't know. No, not there. On the top level. So I'll do a new folder here, and I can, let's say, basics, and it should appear here, and I can copy paste some starting code for myself, so to start learning that, oh yeah, I can manipulate different things and how to move things around until you feel comfortable, and then you can start building up those skills. So pick whatever starting point you wish. You can ask me anything while I move around and have fun. Okay.